One of the fundamental questions of computing is the following. How fast is my program? Right? The whole field of computer science, one of the key things that we're trying to do is automate repetitive tasks such that humans don't have to do it. And one key component of this is that we want our programs to be as fast as possible. So how can we describe how fast a given program is? Well, we can think of measuring maybe how many hours does it take to run? Maybe how many minutes does it take to run? Maybe nanoseconds, some unit of time. Oops, nanoseconds. These are all metrics of human time. And what's nice about these is that they give us some notion of how long the program takes for my user, for someone that's actually running the program. But the problem is a program has two aspects. It has the implementation, which is tied to the programming language, but even more fundamental than the implementation is the algorithm behind the program. And while these different metrics of human time are good at measuring the actual implementation in a program, they don't do a good job describing how fast the idea, the algorithm itself, actually is. So for example, in the early 2000s, I had an old Windows XP computer, and that computer, from the moment you pressed the power button until the moment the operating system was usable, it would take a good minute, 2 minutes, maybe, versus my current laptop, the moment I press the power button, within seconds, I'm at a fully usable state, even from when it was completely off. So in both of these scenarios, the question is, how long does it take my program, which is the operating system, to boot up? Is this how long does an operating system take to boot up actually minutes, or is it actually seconds? Who knows? And the issue is an implementation, a program, will run with different performance depending on what hardware it's run. In 10 years, maybe the same program I wrote today will run much faster because the actual hardware it's running on has more resources or just generally better hardware. So as algorithm thinkers, we don't want to talk about how fast a program is. We want to think about how fast an algorithm is. An algorithm is more of a mathematical higher level description. It's a series of steps that, depending on what hardware or what programming language you choose to implement it, the implementations could be different, but still we have a fundamental algorithm. And instead of describing algorithm performance in terms of human time, we want to describe algorithm performance instead of in terms of number of operations. So given some input size, so number of operations with respect to the input size. So given some input data set of size n, how many operations roughly have to be performed to compute it? So input size, let's say, is n. So to describe time complexity, we want to have some metric of the number of operations. And we'll be talking about different notations of describing time complexity.